Okay, so we now move on to question 16.
Sorry, sir, I have a question.
Sorry?
I wasn't clear on the part which you said that the first one was for dissociation and the other one, is it for bonds making? Oh, I wasn't clear on that one.
Yeah, so bond energy is the energy that is contained in a bond. The energy that is keeping this bond together. The energy that this bond has is the bond energy. Bond dissociation energy is the energy that is used to break the bond apart. That is the differences that are there between bond energy and bond dissociation. Though, even when you want to break the bond, you have to put in the exact amount of energy that is contained in that particular bond. That is the bond that you put in. But when you are defining, that is what it is. Bond energy okay, so bond dissociation, energy required to break the bond. The bond enthalpy is the energy contained in a bond. The other difference is that this is an average and this is not an average. For bromine, it is not an average. For this one, it is an average of 4 CH bonds. Okay, 16. Why might you expect the strength of the CH bond in ethene, which is this molecule? It has CH bonds, to be slightly different from that strength in ethene, CH2 here. Okay, there will be a difference because look at this. There is a single bond between the carbon atoms here. If you check, there is this single bond there, the one I've highlighted in blue. That is a single bond that is there. If you check here, that is a double bond that is there. Because of this, these two carbon atoms are different from these two carbon atoms in terms of hybridization. Because they are differently hybridized, their orbital sizes are different. Because their orbital sizes are different, meaning the bond distances are also going to be different. If the bond distances are different, therefore, the bond strength is also going to be different. So this is where you expect the differences to be, because these two carbon atoms here are sp3 hybridized, meaning they are tetrahedral. These two carbon atoms here are sp2 hybridized, meaning they are trigonoplanar. That in itself tells you the differences in the type of orbitals that they have. These are using sp2 hybrid orbitals. These are using sp3 hybrid orbitals. So the characteristic of the orbitals being used in this one is totally different from the one that is used in that one. And therefore, the bond distances will be different. The bond distance is what determines the strength of a bond. The longer the bond, the longer the bond, the weaker it is. The shorter the bond, the stronger it is. Because of the double bonds that are in here, they make this carbon sp2 hybridized, meaning it forms shorter bonds as compared to sp3 hybridized carbon. So you expect the strength of this to be stronger than that of that one there. Is that clear?
Yes, sir.
Hopefully that is clear. Then 17. How many questions were in this tutorial sheet? All right, 17. Propane and chlorine react in the presence of UV light to give 2-chloropropane among the other things. So there is a given chemical equation, assuming that the reaction is carried out at a temperature where everything is gaseous. Estimate the enthalpy change of reaction of the following bond enthalpies. So you are calculating the enthalpy of this particular reaction there. So you are using bond enthalpies. Since you are using bond enthalpies, the difference that is there in the equations when you are writing an equation where you're using bond enthalpy and when you write an equation where you are using enthalpy of formation is that with bond enthalpy, the reactants subtract the products. With bond formation, the products subtract the reactants. So let me just get a plain paper and write I think the equations, you have them in the books though, that will surely still but when I connect my phone, I think so what I'll do is I'll write and then I'll show you the bundles I've gotten really almost done, the ones we're supposed to use for the day. So I'll write and then hopefully you'll be able to see. So enthalpy of the reaction is equals to the sum of the bond energy of reactants minus the sum of the bond energy of products. So here, what I mean is this. Are you able to see the equation I've written there? Okay, so that is the equation that you're going to use for your bond calculation. So enthalpies are using for bond energy. It is reactants minus products. For bond formation, it is products minus reactants. So all you have to do now here is you are going to start working with your given products. So let us go back to the question. Let us go back to the question. Look at they've given us the bond enthalpies there. So what we're going to do is on the products, so the sum of the bond energy of the products, we're going to do it 1-1. So we're going to say sum of bond energy of products. I'm going to show you after I'm done writing, is equals to, and then you add what is on your product end. So check how many bonds you have. So if you check, you have one HCl bond. So one HCl bond, that HCl bond is 432. That's what they've told us the energy is. It is 432. So 432 plus how many CH3 or how many CH bonds do you have? So for you to know how many CH bonds you have, this here, the top part here, the CH, this CH bond. So I think, okay, let me do this here so that you come and see properly. So I'm going to say you have CCl plus. When it comes to the HC bond, you just count the number of hydrogen atoms you have you have 7 hydrogen atoms in this particular molecule here. In this one, you have 7. 3 here, plus 1 there, 7. So you have 7 CH bonds plus how many CCl bonds do you have? This bond here, 1 CCl bond. CCl bond. So this is how, even when it comes to placing in of the values, that is how you are going to actually do that, and then you find your answer. You also come to the bond of the reactants. So the reactants is going to be equals to CH. How many CH bonds do you have? 8. Plus how many Cl bonds do you have? 1. The Cl bond, you have 1. So Cl bond, Cl like that. So this is going to be 8 multiplied by 413 plus 243. Okay, so what I'm trying to explain to you here is actually this. What I'm trying to explain is this. Once you have written your formula, okay, once you have written your formula like this one here, you have the chemical equation, the formula given there, then you find the sum of the product. So how many HCl bonds do you have on your product? You only have 1. How many CH bonds do you have? So for you to know the CH bonds, you just count the number of hydrogen atoms that are in the molecule. So if you look at your product has 7 hydrogen atoms, meaning there are 7 CH bonds. That's where this 7 is coming from. Plus, how many Cl bonds do you have? Just calculate the number of chlorine atoms you have on your product. It's 1, so 1. And then these are the energies that they have. So when you do this and you total, you will be able to find the energy that is being used here. The same is done on the product. How many CH bonds do I have? I just count the number of hydrogen atoms on my reactant. They are 8. Therefore, 8 there. Plus, how many Cl bonds do I have? Only 1 Cl. So you replace them with their values there and their energies, and you'll be able to find the value. So the value you get here and the value you get there, just place them on that equation there, and you'll be able to find what the enthalpy of the reaction actually is. So that is the ease with which you tend to calculate the enthalpies that are given there. Any questions? Any questions?
Sir.
Yeah.
Just want to find out how best can we tell that there's these are the bond broken, and then these are the bond that are formed in a particular reaction or in a particular in a reactance product.
This is the molecule that you have here, yeah? This is your reactant. This is your product.
Yes.
This is your reactant. This is your product. At this carbon, you have 3 hydrogen atoms. You have 3 hydrogen atoms. On this carbon, you have 2 hydrogen atoms. But when it comes to this one, you only have 1 hydrogen atom, meaning 1 CH bond has been broken and replaced. So 1 hydrogen in here has been replaced by that chlorine that is there. CH3 at the far end, CH3 at the far end. So the product you have here tells you even the location where the bond is breaking from and which bond is breaking. Since there were two hydrogens and you only have one hydrogen there, this simply means the CH bond was being broken and a hydrogen was being replaced by chlorine. So that hydrogen that came from here combined with a chlorine that remains when this chlorine breaks. So when this chlorine breaks, there will be two chlorine atoms. One atom attaches itself there, the remaining atom attaches itself with the hydrogen that is coming from there, and that bond is formed. So does that answer?
Yes, sir. So when calculated, we just take the bond, like the bond broken and the bond formation, like the summation of the broken bond and
In
the
this
summation
particular
of.
case, you've not been given enthalpies of bond formations. What you've been given are the enthalpy of the bonds, meaning the energies that these bonds contain when they have already formed. That's why they're saying bond energy. When they want you to use bond formation, they will state here, they're not going to say bond enthalpy, they're going to say enthalpy of formation. Standard enthalpy of formation is what you're going to be given. You understand?
Okay.
Yeah.
Yes, sir.
So if they give you bond energies, you change the formula. When they give you bond formation, you use the formula for product minus reactants. When they give you the formula, when they give you bond energies, you use reactants minus products as the formula for calculating the same energy, which is the energy of the reaction. Okay, so B, if the reaction occurred.
Sorry, sir.
Yes.
On the part where we have the carbon to carbon bond, is it because it will give us 0 when we subtract? That's why it was left deliberately.
Because there was the carbon-carbon bonds were not tempered with. The carbon-carbon bonds have not been tempered with. They've not been broken. They've not been changed. They've just remained intact. There were 3 carbon atoms in this molecule. There are still 3 carbon atoms in that molecule, meaning they've retained their integrity. So the energy is still the same. And since these two are subtracting, therefore those two will subtract and will still give you 0. So whether or not you are given the energy for the carbons there, since they're not disturbed, what is on the left is going to be subtracted. So the left side is going to be subtracted by the right, meaning if it was 2 for this particular side, there will be 2 on this particular side, and 2 minus 2 is 0. So that is why they didn't give you the bond energy for carbons. Okay, so B, if the reaction is carried out at 298 Kelvin, the standard temperature, that is 25 degrees Celsius, the 2-chloropropane would actually be a liquid. The enthalpy change of vaporization of 2-chloropropane is 27 kilojoules per mole. Calculate the standard enthalpy change for the reaction. So this is the standard enthalpy of vaporization. Okay. And here, okay, look at A. They are saying, assuming the reaction is carried out at the temperature where everything is gaseous, meaning it is in gaseous form, meaning even this product is in gaseous form. But look at what is happening in B. In B, they are telling us that if this was carried out at 28 degrees Celsius, what is going to be produced is actually going to be in liquid form and not gaseous form. Okay? Meaning, when it is formed, it is going to be formed in a